Hello everyone, I welcome you all in my YouTube channel. I am Dr. Sadul Akfaisi. Today in this video I am going to talk about these alterations. I hope this video will be helpful to you. If you like this video, then don't forget to subscribe my channel. So friends, let us start with the Diels alterations. You know, Diels alterations named after Diels and Alder. They received the Nobel Prize in 1950. Produces a carbocyclohexene ring. The reaction is between the diene with an electron deficient alkene dienophile. The Diels-Alder is also called a 4+2 cycloaddition because a ring is formed by the interactions of 4 pi electrons of the alkene with 2 pi electrons of the alkene or alkyne. Mechanism of the Diels-Alder reactions. One step constructed mechanism. A diene reacts with an electron poor alkene dienophile to give cyclohexene or cyclohexadiene ring. These are examples of Diels-Alder reactions. Now, stereochemical requirements. Diene must be in S-cis conformations. Keep in your mind. Diene must be in S-cis conformation. Dienes carbon 1 and carbon 4 p orbital must overlap with the dienophile p orbitals to form new sigma bonds. Both sigma bonds are on same face of the diene seen stereochemistry. Orbital overlap of the Diels-Alder reactions. This is a transition state and this is the products. So S-cis conformations of diene. The S-cis conformations can rotate around the carbon-carbon single bonds to get the more stable S-trans conformations. The S-trans conformation is 12 kJ per mole, more stable than S-cis. So Diels-Alder rate for dienes. Cyclopentadiene undergoes the Diels-Alder reaction readily because of its fixed S-cis conformations. When the diene is sterically hindered, the reaction slows down even though the conformation can be S-cis. So S-trans dienes cannot undergo Diels-Alder reaction, and that is the important point. So stereochemistry of the Diels-Alder reaction, you can see here, cis gives cis meso products, trans give trans products, you see cis give, and like that. Now Indo rule. P orbitals of the electron withdrawing groups on the dienophile have a secondary overlap with the p orbitals of carbon 2 and carbon 3 in the diene. So example of Indo rule is stereochemistry position of norbornene. This is the Indo. Now unsymmetrical reagent 1,4 products. You see the formation of 1,4 produce products. You see 1,4 products, but not 1,3 products. 1,2 products. Now solve problem. Predict the product of the following procedures in evaluation. So the methyl group is weakly electron donating to the diene, and the carbonyl group is electron withdrawing from the dienophile. The two possible orientations place these groups in 1,4 relationship or 1,3 relationship. We select the 1,4 relationship for our predict product. Experimental results show 70 to 30 preference for the 1,4 products. Now this is the second example. Predict the products of the following proposed Diels-Alder reactions. So pericyclic reactions. Diels-Alder reaction is an example of pericyclic reaction. Woodward and Hoffman predicted reaction products using their theory of conservations of orbital symmetry. Molecular orbital must overlap constructively to stabilize the transition state. So symmetry allows transitions. allowed reactions. Diene contributes electrons from its lowest energy occupied orbital, and dienophile receives electrons in its lowest energy unoccupied orbital. So forbidden cycloadditions. 2 plus 2 cycloaddition of 2 ethylene to form cyclobutene has anti-bonding overlap of HOMO and LUMO. Anti-bonding interactions. Photochemical inductions. Absorptions of correct energy photons will promote an electron to an energy level and that was previously unoccupied. So 2 plus 2 cycloaddition photochemically allowed but thermally forbidden. LUMO, HOMO, you can see. Ultraviolet spectroscopy. 200 to 400 nanometer photons excite electrons from a pi bonding orbital to a pi star antibonding orbital. Conjugated dienes have molecular orbitals that are closer in energy. A compound that has a longer chain of conjugated double bonds absorb light at longer wavelength. This is the pi to pi star transition for ethylene and butadiene. Obtaining a UV spectrum. A spectrophotometer measures the intensity of reference beam through the solvent only I and the intensity of beam through a solution of the sample I. The observance is the log of the ratio IF by IS. So the UV visible spectrum usually shows broad peak. Read lambda max from the graph. Absorbance A follows Beer's law. So A is equal to epsilon CA, where epsilon is the molar absorptivity, C is the sample concentration in moles per liter, and L is the length of the light path in centimeters. So this is the UV spectrum of isoprene, 2 double bonds, conjugations, some UV absorptions of other compounds. Now Woodward-Fisher's rule. Woodward-Fisher rule for conjugated dienes value for oxochrome groups. So there is some rule. Another conjugated double bond plus 30, alkyl group plus 5, alkoxy OR group 0. If one of the double bond in the chromophore is exocyclic and another 5 nanometer. So this is the rank the following dienes in order of increasing value of lambda naught and their actual absorption maximum 185 nanometer, 235 nanometer, 273 nanometer and 300 nanometers. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.